On the 4th of July, 1956, a Myasishchev M4 Bison strategic bomber was plotted by the Chain Home Extended Radar Network at a height of 58,000 feet, tracking west-southwest across the Barents Sea towards the Norwegian coast. The duty controller at RAF Buchan logged the contact at 0417 Greenwich Mean Time. The Gloucester Javelin FAW Mark IV squadrons held at readiness across East Anglia possessed a service ceiling of 52,000 feet. The intercept, quite simply, could not be flown. A minute from the Assistant Chief of the Air Staff, Air Vice Marshal Geoffrey Tuttle, circulated within the Air Ministry the following week and survives today in the National Archives at Kew under reference AIR 20/10,742. Its conclusion was stark. Every frontline fighter in Royal Air Force service, and by extension, every interceptor fielded by the North Atlantic Treaty Organization, was incapable of engaging the new generation of Soviet high-altitude bomber at its operational cruise. The strategic consequence was immediate. The Bison was understood by the Joint Intelligence Committee to be the carrier of the RDS-37 thermonuclear weapon, a device tested at Semipalatinsk on the 22nd of November 1955 with a yield of 1.6 megatons. The Air Staff assessment was that a single Bison penetrating to the English Midlands at height could deliver a weapon capable of destroying Birmingham and contaminating ground from Coventry to Wolverhampton. Supermarine Swifts and Hawker Hunters, the mainstays of fighter command, were effectively blind to the threat. Radar at RAF Neatishead could see the bombers. The guns, however, could not reach them. The response was drafted within the old Air Ministry building on Kingsway during the autumn of 1956, in parallel with the Suez Crisis, which consumed much of the Cabinet's attention. Duncan Sandys, shortly to author the infamous White Paper of 1957, chaired a series of meetings with the Vice Chief of the Air Staff and representatives from the Ministry of Supply. The minutes, now catalogued as CAB 128/30, record a specific demand: a manned interceptor capable of engaging a target at 60,000 feet within 10 minutes of scramble, armed with a guided weapon and fitted with airborne interception radar of sufficient aperture to acquire a bomber-sized return at 25 nautical miles. The altitude requirement was subsequently revised upwards to 65,000 feet, following further intelligence assessments of the Tupolev Tu-Ninety-Five Bear, which had entered operational service with the Soviet long-range aviation in 1956. The Royal Aircraft Establishment at Farnborough, working in concert with the Defence Research Policy Committee, concluded that no existing airframe could be modified to meet the brief. The American Convair F-102 Delta Dagger, offered informally through United States Air Force liaison channels, possessed a ceiling of 54,000 feet and was dismissed by Air Marshal Sir Thomas Pike as, in his words, preserved in a marginal note, inadequate by margins that matter. The French Dassault Mystère was similarly unsuitable. The conclusion forced upon Whitehall was uncomfortable and expensive. Britain would have to build the aeroplane herself, and she would have to build it to a specification so extreme that the Royal Aircraft Establishment's own aerodynamicists were uncertain whether the laws of transonic flow would permit it at all. The document which emerged from that assessment, Specification F.Twenty-Three/49, would shape British air defence for the following 3 decades and produce, in the fullness of time, an aeroplane capable of reaching heights no NATO fighter has touched since. Specification F.Twenty-Three/49 was issued by the Ministry of Supply on the 1st of April 1949, 7 years before the Bison overflight that would render its urgency absolute. The document, drafted principally by Maureen Morgan at the Royal Aircraft Establishment, demanded a research aircraft capable of sustained flight at Mach 1.5 at 50,000 feet. The brief was deliberately experimental in framing because the Treasury, still administering post-war austerity under Stafford Cripps, would not have sanctioned a frontline combat aeroplane of such ambition. The specification was, in practical terms, a covert operational requirement dressed in academic clothing. 5 firms submitted proposals. Hawker, Supermarine, Fairey, and Bristol produced designs broadly conventional in layout, with swept wings of between 40 and 45 degrees and single engines of the Avon or Sapphire family. The proposal that arrived from English Electric's Preston drawing office on the 14th of December 1949 was of an entirely different character. It bore the signature of William Edward Willoughby Petter, known throughout the industry as Teddy Petter, the chief engineer who had designed the Westland Lysander and the Canberra bomber. Petter had resigned from Westland in 1944 over a dispute regarding centralised decision-making, and at Preston he had assembled a team including Frederick Page and Ray Creasy, the latter a specialist in supersonic aerodynamics who had spent the war years at the Royal Aircraft Establishment working on compressibility research. The English Electric submission, designated P1, proposed a wing swept at 60 degrees. No British aeroplane had ever flown with such extreme sweep. The Americans had produced nothing comparable. The Bell X-5, a variable geometry research aircraft, managed 58 degrees only in its fully swept configuration. Petter's reasoning, documented in the company's internal aerodynamic report EE/P1/007, was that sustained supersonic flight at altitude demanded a wing thin enough to avoid wave drag and swept sharply enough to keep the leading edge subsonic at Mach 1.5. The resulting planform resembled an isosceles triangle with the tips clipped and provoked considerable skepticism at Farnborough. More radical still was the engine arrangement. Petter proposed to mount 2 Rolls-Royce Avon turbojets, not side by side, as the Americans had done with the F-101 Voodoo, but one above the other in a vertical stack, staggered so that the upper engine sat slightly further aft. The configuration offered a frontal area barely larger than that of a single-engined fighter, permitting a fuselage of minimal cross-section and therefore minimal transonic drag. It was aerodynamically elegant and mechanically unprecedented. The Ministry of Supply's assessors at Thames House initially refused to believe the intake geometry would function. Ray Creasy's wind tunnel data, gathered at the Royal Aircraft Establishment's supersonic tunnel at Bedford, eventually persuaded them. The contract for 3 P1 prototypes was signed on the 1st of April 1950, valued at £750,000. A second contract, issued in 1954 under revised specification F.Twenty-Three/49 Issue 2, called for development of the research airframe into an operational interceptor with provision for airborne interception radar, guided weapons, and afterburning engines. By this point, Petter had left English Electric, departing in 1950 following disputes with the board at Stowe House over resource allocation. Frederick Page inherited the program and would remain its guiding hand for the next 20 years. The aeroplane that would emerge from the Wharton factory bore Petter's conceptual fingerprints on every surface, but it was Page who translated the research design into the weapon system that Fighter Command would come to know as the Lightning. The first P1 prototype, serial number WG760, was transported by road from Wharton to the Aeroplane and Armament Experimental Establishment at Boscombe Down in the last week of July 1954. The convoy travelled by night, the airframe sheeted in tarpaulins, escorted by Royal Military Police vehicles on a route approved by the Ministry of Supply's Security Branch. Wing Commander Roland Prosper Beaumont, English Electric's chief test pilot and formerly commander of No. 150 Wing Flying Tempests against V-1 flying bombs in 1944, had been appointed to conduct the initial flight program. Beaumont was 40 years old, held the Distinguished Service Order with 2 bars and the Distinguished Flying Cross with 1 bar, and had already flown the Canberra prototype 3 years earlier. The maiden flight took place on the 4th of August 1954 at 0958 hours. Beaumont lifted WG 760 from Boscombe Downs main runway 06-24, climbed to 15,000 feet over Salisbury Plain, and spent 33 minutes assessing basic handling. The aircraft was fitted with 2 Armstrong Siddeley Sapphire ASSA.5 engines of 7,500 pounds static thrust each, the Avon installation being reserved for the operational variant. Beaumont's post-flight report, filed that afternoon and preserved at the Royal Air Force Museum, Hendon, under accession number X004/421, noted that the aeroplane was conventionally pleasant at subsonic speeds and exhibited no vices of handling requiring remedial action. It was the 3rd flight, on the 11th of August, that altered the strategic calculus. Beaumont had been instructed by Frederick Page to conduct a gentle acceleration in level flight at 30,000 feet, not to exceed Mach 0.98. The airspeed indicator passed through Mach 1.02 before Beaumont registered the transition. There had been no transonic buffet, no trim change, no control reversal. The aeroplane had gone supersonic in level flight without afterburners, a feat no British aircraft and no operational American fighter had previously achieved. Beaumont held the condition for 42 seconds, then throttled back and returned to Boscombe Down. His telephone call to Page at Wharton, routed through the Boscombe Exchange at 1612 hours, lasted 4 minutes. The implications travelled rapidly through the British defence establishment. Air Marshal Sir Dermot Boyle, Chief of the Air Staff, was briefed the following morning at the Air Ministry on King Charles Street. A liaison signal to the British Joint Services Mission in Washington, transmitted on the 16th of August, summarised the figures for General Nathan Twining's office at United States Air Force Headquarters. The American response, received through Air Commodore Geoffrey Millington at the British Embassy on the 23rd of August, requested permission to send evaluation pilots. The request was declined by the Ministry of Supply pending completion of Phase 2 trials, a delay that caused considerable irritation at Wright-Patterson Air Force Base. The Royal Aircraft Establishment's assessment, compiled by Handel Davies and distributed to the Defence Research Policy Committee on the 9th of September, concluded that the P-1 airframe possessed excess performance margins sufficient to accommodate the full operational fit of radar, missiles and afterburning engines, whilst retaining a substantial climb and altitude advantage over any projected Soviet interceptor. The aeroplane, Davies wrote, would reach 50,000 feet in under 3 minutes from brake release when fully developed. The figure provoked scepticism at Farnborough and disbelief in the Treasury. Both would prove mistaken. The second prototype, WG 763, flew in July 1955, fitted with a modified intake and the first signs of what would become the operational Lightning's distinctive planform. The Rolls-Royce Avon had entered Royal Air Force service in the Canberra B Mark II in 1951 at a rating of 6,500 pounds static thrust. By the time English Electric required engines for the operational Lightning, the type had been developed through a dozen marks at the Derby Works under the direction of Stanley Hooker, and following Hooker's departure to Bristol in 1949 under Adrian Lombard. The variant selected for the Lightning F Mark I was the Avon 210, also designated RA-24R. Each engine produced 11,250 pounds of static thrust in full reheat, drawing fuel through a four-stage centrifugal pump at a peak rate of 980 gallons per hour. The reheat system, developed at the Rolls-Royce experimental establishment at Hucknall under Frederick Morley, used a variable area convergent nozzle actuated by engine bleed pressure. Two such engines in a single airframe produce 22,500 pounds of reheated thrust. The Lightning F Mark I at combat weight of 31,000 pounds therefore possessed a thrust-to-weight ratio of 0.725. The contemporary McDonnell F-101 Voodoo managed 0.54. The Convair F-106 Delta Dart, America's premier interceptor, achieved 0.71 only at light fuel states. The Dassault Mirage 3, entering French service in 1961, reached 0.62. The Lightning was, by a measurable margin, the most powerful fighter per pound in NATO inventory, and it owed that distinction almost entirely to Petter's decision to stack two engines where his contemporaries had fitted one. The stacked configuration presented engineering difficulties that occupied the Wharton team for the better part of 3 years. The upper engine, designated number 2, was mounted at a 5-degree upward incline to the thrust axis and offset rearwards by 42 inches from the lower engine. Its intake was ducted over the cockpit through a bifurcated trunk that split the airflow from the single-nose intake into upper and lower streams at frame number 17. The aerodynamic accountancy was exacting. Ray Creasy's team at Wharton calculated that pressure recovery at the upper engine face fell below 94% at Mach 1.8. A loss sufficient to provoke compressor stall if the intake geometry was misjudged by even a fraction of a degree. The solution was a translating center body in the nose, intake, a conical shock generator that moved fore and aft by 6 inches in response to Mach number, regulating the shock pattern to maintain subsonic flow at the compressor face. The lower engine drove the forward bay accessories, including the 115-volt alternator that powered the Ferranti AI.Twenty-Three radar. The upper engine drove the hydraulic pumps for the powered flying controls, operating at 3,000 pounds per square inch. Fuel was carried in integral wing tanks of 716 gallons total capacity, supplemented by a ventral tank of 250 gallons on the F Mark 1A and subsequent marks. This fuel fraction, approximately 23% of operational weight, was notoriously inadequate. A Lightning at full reheat consumed its entire internal fuel load in approximately 11 minutes. The climb performance the engines conferred was, however, without equal in Western service. From brake release at RAF Coltishall, a Lightning F Mark III could reach 40,000 feet in 2 minutes and 40 seconds. The zoom climb, a ballistic maneuver in which kinetic energy at low altitude was converted to potential energy above the service ceiling, would extend that envelope to figures that astonished even those who had designed the aeroplane. Mike Hale's flight in 1962 would demonstrate precisely what 22,500 pounds of reheated thrust could achieve when the pilot was willing to push the airframe beyond every published limit. The Ferranti AI.Twenty-Three radar, known to its operators as AirPass, was the first airborne interception set in NATO service to combine search, track, ranging for gun attack and missile guidance in a single integrated installation. Development had commenced at Ferranti's Edinburgh Works in Crewe Toll in 1954 under the direction of Arnold Wilkins, formerly of the Telecommunications Research Establishment at Malvern, and one of the original authors of the Chain Home Specification in 1935. The set operated in the I band at a frequency of 8.5 to 9.6 gigahertz, transmitted through a 24-inch parabolic dish mounted within a dielectric radome in the Lightning's nose intake center body. Peak power output was 100 kilowatts, pulse repetition frequency 1000 Hz, and maximum search range against a medium bomber target approximately 40 nautical miles. The installation within the translating intake center body was itself a considerable engineering achievement. The radome had to be transparent to 9 GHz energy whilst withstanding aerodynamic heating of 140 degrees Celsius at Mach 2, structural loads of 8G during maneuver, and the shockwave buffeting of supersonic flight. The material selected was a laminated fiberglass impregnated with a silicone resin developed at the Royal Aircraft Establishment's materials branch at Farnborough. The conical profile also functioned as the supersonic shock generator for the engine intakes, meaning that the radar antenna and the engine air supply shared a single structure whose geometry had to satisfy both electromagnetic and aerodynamic requirements simultaneously. No other fighter in the Western inventory attempted such an integration. The weapon the radar guided was the de Havilland Firestreak, designated Blue Jay in development and issued to No. 74 Squadron at RAF Coltishall in July 1960. The missile was 31.5 inches in diameter, 10 feet 4 inches long, and weighed 300 pounds at launch. Propulsion was by a Magpie solid fuel motor burning for 1.7 seconds, accelerating the weapon to Mach 3. The warhead was a 50-pound continuous rod fragmentation device surrounding a proximity fuse developed at the Royal Armament Research and Development Establishment at Fort Halstead in Kent. Guidance was by lead sulfide infrared seeker, cryogenically cooled by anhydrous ammonia to minus 180 degrees Celsius to improve sensitivity against the exhaust plume of a jet bomber. The seeker could acquire a Tupolev Tu-95 at a range of 5 nautical miles from the rear quarter under clear conditions. The tactical geometry this imposed was unforgiving. Firestreak was a pure stern chase weapon, requiring the Lightning to maneuver into a cone approximately 40 degrees wide behind its target before launch. At interception, altitudes above 50,000 feet, where the air was too thin for sustained turning, this positioning demanded that the ground controller deliver the fighter to a precise point in space with a heading error of less than 10 degrees. The controller sat not in the aeroplane, but on the ground at one of the master radar stations of the Linesman mediator network. Linesman, operational from 1964, linked 4 primary sites: RAF Neatishead in Norfolk, RAF Staxton Wold in Yorkshire, RAF Bolmer in Northumberland, and RAF Buchan in Aberdeenshire through a hardened communications grid centred on the Strike Command bunker at High Wycombe. Data was transmitted to the Lightning via a narrowband, ultra-high frequency link operating at 250 MHz, providing the pilot with target bearing, range, and closure rate through a tape display mounted below the main instrument panel. The kill chain ran from a rotating aerial on a Yorkshire moor, through a concrete bunker at Borburg, through a fighter controller's voice, into the cockpit of a Mach 2 aeroplane over the North Sea. It worked, and it worked repeatedly. Squadron Leader Michael John Hale had joined the Royal Air Force in 1951 and arrived at the Air Fighting Development Squadron at RAF Binbrook in Lincolnshire in August 1961. Binbrook, situated on the Lincolnshire Wolds at an elevation of 373 feet above Mearns sea level, was the Royal Air Force's principal trials and evaluation establishment for the Lightning. The airfield's runway 03/21 measured 7,500 feet in length, and its proximity to the North Sea ranges off Spurn Head made it ideal for supersonic trials. Hale had previously flown the Hawker Hunter Mark 6 with No. 43 Squadron at RAF Luchars and had accumulated 420 hours on type before converting to the Lightning in 1960. The zoom climb profile had been developed at the Royal Aircraft Establishment's Aeroflight at Bedford by a team working under Handel Davies. The technique exploited a fundamental principle of energy state aerodynamics. An aeroplane in level flight at high subsonic speed possessed kinetic energy proportional to the square of its velocity. If that kinetic energy could be converted efficiently into potential energy through a carefully flown pull-up, the aircraft could coast ballistically to altitudes far exceeding its sustained service ceiling, arriving at the apex with minimal airspeed but having achieved heights at which no adversary could operate. The technique had been pioneered by the Americans with the Lockheed F-104 Starfighter during the 1958 and 1959 period. But the Starfighter lacked the power reserve to make the climb meaningful at combat weight. The Lightning, with its thrust-to-weight ratio approaching unity in the clean configuration, possessed energy reserves no other NATO fighter could match. Hale's trial was flown on the 14th of November 1962 in a Lightning F Mark III, serial number XP744, configured in clean fit with no external tanks, no missiles, and fuel loaded to 42% of internal capacity. Ground crew had removed the gun pack from the ventral bay to reduce weight by a further 212 pounds. The briefing at Binbrook operations at 0745 hours specified a climb profile developed by the Royal Aircraft Establishment's Wing Commander Paddy Harbison. Hale was to accelerate to Mach 0.9 at 30,000 feet over the North Sea, approximately 40 nautical miles east of Spurn Head. Then pull into a 30-degree climb, accelerating through Mach 1.3 at 40,000 feet, and Mach 2.0 at 55,000 feet. At 65,000 feet, he was to select full reheat and rotate to an 80-degree pitch attitude, allowing the aeroplane to ballistic coast to its apex with the engines at flight idle above 70,000 feet, where combustion stability could no longer be guaranteed. The flight departed Binbrook at 0912 hours. Hale reached his initial point at 0926 and commenced the climb. The apex was recorded by the aircraft's pressure altimeter at 87,300 feet. Telemetry from the Royal Aircraft Establishment's tracking radar at Staxton Wold confirmed the figure within a margin of plus or minus 400 feet. Hale was at that moment higher than any operational NATO fighter had ever flown. The Soviet Union possessed nothing capable of matching the achievement. The Lockheed U-2, a reconnaissance aircraft rather than an interceptor, could loiter at 70,000 feet but could not engage in combat. The SR-71 Blackbird would not fly operationally until 1966. For a brief moment on a November morning above the Lincolnshire coast, Squadron Leader Hale occupied an altitude that the North Atlantic Treaty Organization's air forces would never again routinely reach. The Tupolev Tu-95 Bear had entered Soviet long-range aviation service in 1956 and by the early 1960s was operating reconnaissance variants of the type, principally the Tu-95 RT, from bases at Olenya on the Kola Peninsula and Semipalatinsk in Kazakhstan. The maritime reconnaissance sorties flown against the Royal Navy's home fleet followed predictable tracks. A Bear departing Olenya would route northwest across the Barents Sea, descend through the Greenland-Iceland-United Kingdom gap at approximately 30,000 feet, and then turn south along the Norwegian coast to photograph naval activity at Skarpa Flow, Rosyth, and Faslane before routing home via a reciprocal track or, on occasion, continuing around the Iberian Peninsula to recover at Cuban bases. The first Royal Air Force interception of a Tu-95 by Lightnings occurred on the 20th of April 1963. A pair of Lightning F Mark IIs of No. 19 Squadron launched from RAF Leconfield at 0642 hours on a Tango scramble ordered by the master controller at RAF Patrington. Flight Lieutenant Terence Bond, leading Red Section, established visual contact with the Bear at 32,000 feet, approximately 190 nautical miles northeast of Flamborough Head. The photograph taken by Bond's wing camera, released to the press by the Air Ministry 3 weeks later, became one of the defining images of British Cold War air defence. It showed the white-painted Lightning formatting close alongside the olive-green Soviet bomber, the red stars on its fuselage clearly legible. The pattern thus established would be repeated approximately 400 times during the decade that followed. Quick reaction alert pairs were held at 2 minutes readiness at RAF Lochars in Fife and RAF Binbrook in Lincolnshire, with a third pair at RAF Wattisham in Suffolk after 1967. The alert aircraft sat in hardened shelters with engines wired for immediate start, pilots in the crew room in full immersion suits, and the telebrief line from the sector controller at RAF Buchan or RAF Neatishead permanently open. The typical interval from scramble order to wheels up was under 3 minutes. A Lightning F Mark VI on full reheat could reach a Bear at 65,000 feet and 200 nautical miles from the coast in less than 10 minutes. The tactical procedure was governed by Air Defence Operations Centre Standing Order No. 47, which required the interceptor to establish visual identification, photograph the target, and remain in company with the contact until it departed the United Kingdom Air Defence region. No engagement was authorised unless the target penetrated territorial airspace, a line extending 12 nautical miles from the coast. The Lightning was armed with 2 Firestreak missiles, later red-top missiles in the F Mark III and F Mark VI variants, and 2 30mm Aden cannon in the ventral pack. The cannon were live. The missiles were wired but not enabled. The photographs, developed at the Joint Air Reconnaissance Intelligence Centre at RAF Brampton in Huntingdonshire, were on the desk of the Director of Air Intelligence at the Ministry of Defence within 48 hours. The psychological effect upon Soviet aircrew of encountering a Lightning at altitudes previously considered safe was documented in defector debriefs held by the Secret Intelligence Service. Lieutenant Colonel Viktor Belenko, who defected in a MiG-25 to Hakodate in 1976, reported during his subsequent interrogation that Soviet bomber crews had been specifically briefed on the British interceptor's climb performance and had been instructed to avoid prolonged loiter in the Greenland-Iceland-United Kingdom gap. The Lightning had, by its mere existence and demonstrated capability, altered the operational behavior of the Soviet long-range aviation. The replacement program that would eventually retire the Lightning had its origins in Air Staff Target 357, issued in 1968 for a multi-role combat aircraft to succeed the Canberra, the Vulcan, and in due course the Lightning itself. The program evolved through the Anglo-French Variable Geometry Project, which collapsed in June 1967 when France withdrew and emerged finally as the Panavia Tornado, a tripartite venture between the United Kingdom, West Germany, and Italy. The air defense variant, designated Tornado F Mark III, entered service with No. 29 Squadron at RAF Coningsby in November 1987. Its specification, in the specific matter of altitude, fell considerably short of the aeroplane it was designed to replace. The Tornado F Mark III possessed a service ceiling of 50,000 feet and a combat ceiling at which sustained maneuver remained possible of approximately 43,000 feet. Its zoom climb capability was not advertised by British Aerospace's Wharton division because the airframe, optimized for low-level penetration and medium-altitude intercept using the Foxhunter radar and Sky Flash missile, was structurally and aerodynamically incapable of ballistic coasting to the heights the Lightning had routinely achieved. The Foxhunter radar, developed by Marconi Avionics, possessed a detection range of 120 nautical miles against a bomber target, considerably in excess of the Ferranti AI.Twenty-Three, and the Skyflash missile offered a semi-active radar homing engagement envelope unconstrained by rear quarter geometry. These were real tactical advantages. They did not, however, restore the altitude ceiling that the Royal Air Force was about to surrender. The final Lightning squadrons at RAF Binbrook, No. 5 and No. 11, flew their last operational sorties on the 30th of April 1988. The disbandment parade was held in light drizzle at Binbrook on that date, inspected by Air Chief Marshal Sir David Craig, Chief of the Air Staff. 5 Lightning F Mark VIs performed a final diamond flypast at 1,000 feet over the airfield, led by Squadron Leader Ian Black. The remaining airworthy airframes were flown out to storage at RAF St. Athan in Glamorgan during May and June. A small number were retained by British Aerospace at Wharton for radar target duties, flying until 1992 when the last Lightning in British skies, XP-693, was retired. The strategic consequence of that retirement has persisted for nearly 4 decades. No fighter in the inventory of the North Atlantic Treaty Organization has since demonstrated a zoom climb ceiling approaching 87,000 feet. The Eurofighter Typhoon, which entered Royal Air Force service in 2003, possesses a service ceiling of 55,000 feet and has been demonstrated to reach approximately 65,000 feet in a zoom profile. The Lockheed Martin F-22 Raptor achieves similar figures. The F-35 Lightning II, confusingly named and operationally dissimilar, reaches 50,000 feet. None comes within 15,000 feet of Squadron Leader Hale's achievement over the Lincolnshire coast in November 1962. The reason, in the final analysis, lies not in any degradation of engine technology or aerodynamic understanding, but in a shift of tactical philosophy. The threat the Lightning was built to counter, the high-altitude manned bomber carrying a free-fall nuclear weapon, ceased to exist with the deployment of intercontinental ballistic missiles and sea-launched cruise weapons. Altitude ceased to be the critical discriminator of air combat. Stealth, sensor fusion, and beyond visual range engagement replaced it. The Lightning's 87,000 feet stands today as a monument not to obsolete engineering, but to a strategic problem that, for one brief decade, the Royal Air Force solved more comprehensively than any of its allies.